So this is Algebra 1, 4.7. We did skip 4.6. Today we're going to talk about inverse linear functions. Okay? But first, before we start getting into functions and equations, let's just talk about relations. So what's an inverse relation? Well, let's back up even further then and say, what's an inverse? What do you think of inverse? Sometimes people say opposite, right, in a way. The inverse of going that way is the other way, right? Going left, the inverse is going right. Think of it this way. If something of a machine, okay, let's think of a machine even. If a machine started off with a chair and made a table out of it, or a tree, let's just say a tree, and made a table out of it, the inverse machine would be what? Taking the table and making a tree again. It's kind of putting things back where they were, right? So that's the same exact things what we're going to think about here for an inverse relation. It is the set of ordered pairs obtained by exchanging the x-coordinate with the y-coordinate with each ordered pair in the relation. That seems pretty easy, actually. If one relation contains an element of A, B, then the inverse relation will contain the element B, comma, A. What are you going to do? Switch X and Y. If you wanted to know, if you're given a set of points, a set of data in a table, in a mapping, in an ordered pairs, all you need to do is take the X's and the Y's and switch their places. The inputs become the outputs become the inputs. So, we got two examples there. One is a set of points and the other one is in a table. Can you create the set of points for the inverse relationship for A? And can you create the inverse table for part B? I'm going to give you guys an opportunity to try these on your own first before we come together. So the first set would be, oops, wrong, 8, negative 6, and keep going. And?
3 and 9.
And 6 and 0. Does everybody agree? All I did was switch X and Y. Who has a table? Who can give us a table? Chuck?
5 over -10, 11 over -4, 12 over -0.
Right, so all we're going to do is switch X and Y again, making our table. Any questions on that, guys? Pretty straightforward, right? So, the next one here, guys, is, and I really don't have an example for this one because it's not that much different than what you just did on the last page. But what if they say, hey, I have a graph, right? Here's a graph. Can you graph the inverse of that graph? I think it's pretty straightforward. I don't need to do an example because there's only 3 steps. Remember that a relationship or a line is a relationship, so we can switch X's and Y's. So if I'm just given a graph, what I'm going to do, guys, is in step 1, I'm going to identify, right, several points on the line. I'm going to identify nice points, guys. Notice that they're in quotations. They mean nice because I'm looking for those intersection of grid lines. I'm looking for whole numbers or halves. Things that you can pretty much say, I know that point. We kind of talked about that yesterday with our scatter plots. Once you find those points, what are you going to do? Switch x and y. And when you switch your x and y, those are the inverse, and therefore you can graph those. Now you have your inverse graph. So where does this all come down to? It all comes down to actually finding inverse functions. And the cool thing is, you guys really only know about linear functions, lines. But guess what? Quadratics and cubics and cubed roots and all these different things, exponents, they have inverses too sometimes. And so, you can use the same process on those too. So this is something you're not going to want to forget as well. That if you want to find the inverse function, the first thing I'm going to do is recognize, are they using function notation, that f of x stuff? And if they're using function notation, switch out of it. Set it equal to y. We like x's and y's instead. Then, in step 2, switch x and y. Because if I put the inputs to the outputs to the inputs, I just basically found the inverse. But since we're finding an inverse function, you need to then solve for y. So really what it comes down to, guys, these two steps right there are the main focus. Switch x and y and solve for y. The rest of it is just semantics. You can change in step 4 the y back to function notation, the f of x stuff. But notice that this time it looks slightly different. The y of the inverse function, the one that you're going to claim is the inverse, we like to put a little -1 above the f. So it's f inverse of x. Now sometimes people get a little bit on the lazy side and don't use function notation. They may even go like this. A y with a little -1. Y inverse. Y inverse, f of x inverse. Basically, it's some way for us to denote that one of them's the original function and one's the inverse. Even though those wordings actually should be able to be switched, right? Because if something's the inverse of another thing, looking from the other perspective, they're inverses of each other, so therefore they can be called both inverses. You guys get that what I'm saying? School to home and home to school, it's kind of like, it's the same thing, it's just from a different perspective. One's the inverse or the opposite way of the other. Okay, they both undo each other in that way. So, I want you guys, we'll do step 1 or part A together, because this one is a little bit more involved. And then step or part B, you guys will try, and then we'll come back together. So, this is f of x notation. Change it to what? So y equals 4x minus 12. Now, step 2. Switch x and y. X equals 4y minus 12. We like that. And now, using your algebra skills that you guys have been building, solve for y. And how do we do that, guys? Add 12 to both sides. So it's x plus 12 equals 4y. Get y by itself? No. Divide both sides by 4. So y equals, guys, I'm not going to leave it like x plus 12 over 4. I'll separate those. And what would those separated be? So remember, we got to break that up. X over 4 plus 12 over 3. Or 12 over 4, which is 3. Guys, so even at this point, I didn't simplify the 12 over 4. I'll do that in the next step. Look at this. Right away, I'm going to put y inverse there. I got y by itself at this point. I'm kind of denoting that, hey, this is the inverse. And so when I go to clean this up, say y inverse equals x over 4 plus 3. And if I wanted to switch it back because it was originally in function notation, it would be what? F, little negative 1, so f inverse of x equals x over 4 plus 3. Now, if you guys don't like x over 4 really looks like what in slope-intercept form, though? Like, what would it be? 1 over 4 x plus 3. So if you guys saw x over 4 plus 3, would you guys recognize that it has a slope of 1/4? Okay, you need to be able to recognize that because I may ask you to graph those. Okay, I'm going to give you guys a couple seconds for 1/3 x plus 7. F of x equals 1/3 x plus 7. Give it a shot. So, what's your process? Talk us through it.
So you change that to a y. And then you change the y to the x, and you switch the y and the x.
Slide with 2 fingers. If you need to look on the screen up.
And then I subtracted the 7. So what you have to do is you have to multiply it by 3. And that will give you yes.
Okay, does everybody agree with Luke?
No.
Oh, okay. Let's back up. Do we agree with almost 90% of his work? Yes. There's 90% agreement here, guys. There's one thing that I think that Luke kind of messed up at the very end. Was the fact that he goes and writes multiply by 3 on this side, but did you write multiply by 3 on this side? No. And to make it easier for yourself, I would put parentheses and put a 3.
Okay.
So what do you see you did wrong?
Oh, it's 3x.
You forgot to distribute the 3 to the x as well. So the answer, or inverse y, right, is 3x minus 21, which if I move it up here, we get f inverse of x equals 3x minus 21. Everybody in agreement now? Okay. So we should be liking these. They're not too bad. Remember the steps. Switch x and y and solve for y. Solve for y could mean adding, subtracting, multiplying, dividing. It has its own set of steps, and that goes back to solving one-step, two-step equations from all the way back into like quarter 1. This is why sometimes when people ask me, okay, Mr. Concha, can I throw away my stuff from first semester? And I'm thinking, I am not going to give you the yes or the no. You need to make the decision. If you don't need to look back at this stuff, then sure, go ahead, I guess. But I necessarily wouldn't throw something away while I'm still in that class.
Where'd you go to college?
Okay, guys. Guys, we're going to use an inverse function to our advantage, because obviously the question is, where will I ever use this in real life? there's a couple different ways we can do this, guys. We, can try to set up an equation sometimes and work our numbers until we get an answer we want. Or we could take an equation, find its inverse, plug in the answer that we originally wanted to find, and it'll spit out an answer that we need to put into the original function, if you can follow that. That's basically what we're going to do here. It says Peggy needs or rents a car for the day. The total cost, C of x, in dollars is given by C of x equals $19.99 for the low price of $19.99 plus 0.3x is the equation, where x is the number of miles she drives. So obviously, the more miles she drives, the more the car will cost. Yes?
Yes.
Basically 30 cents a mile. 30 cents a mile added to $19.99. So if she drives 10 miles, it's going to cost her an extra $3. If she drives 100 miles, it's an extra $30. Guys, in part A, it wants you to find the inverse function, C inverse of x. So please do that. I'll pause it so we don't have to have a 25-minute video. So, I'm going to speed things up just a little bit. I'm going to already start off with y equals 19.99 plus 0.3x. Switch it up, right? Plus 0.3y. Next step. Fritz. Subtract 19.99. So x minus 19.99. Dun, 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 dun. Sorry. You guys even get that reference or no?
I do.
Okay, like one person. It's sad, guys.
Wait, was it? Is it?
Okay.
Is it a song?
It is a song. Okay, guys. It is Prince. Here's the thing, guys. I want to get rid of the 0.3. So obviously, to get rid of a multiplication of 0.3, you can divide by 0.3. But here's the thing. Then you're left with an x over 0.3. I don't think anybody, would look in a book and say, hey, look, I got a 1 over 0.3 and be happy with that. Any kind of solution manual, any kind of reduced format. What is 0.3 as a fraction? Maybe that'll help us. How would I read that?
3/10.
It's 3/10. What's the fraction?
3 over 10.
3 over 10. So, if I wanted to get rid of 3 over 10, I multiply both sides by 10 over 3. Can you guys visualize that? You guys remember, guys, this, I'm going to change colors so we can break out here. This is really 3 over 10. These will cancel. Right? It allows me not to have to worry about dividing by 0.3. So, I end up with 10 thirds x minus 199.9 over 3 equals y inverse, or equals c inverse of x. We found it. It's still not perfect because we have a decimal inside a fraction, but it's a lot better than dividing by, 0.3. We could fix that still, multiplying the top and bottom by, what? By 10? Ooh, we're going to run out of time pretty soon here. What do x and c inverse actually represent in this problem now? That was A. What is B? What does it mean? What does x represent in our new equation? Okay, let's go back. What did x represent over here? Miles. But now it's not miles in this one. It's the... What was y in the first equation? cost. Remember, they switched places, right? So now x is the cost, and C inverse of x is the miles. So now the input is the cost. The output would tell me exactly how many miles she will drive. So if I want to know how far she drives for $34.99, I can use my inverse equation. And I'll let you guys plug it in because it's just evaluating the function. Your homework is on page 267, 1 through 7, 48 through 56. Have a great day.